the working software, and more specifically, the software that works on large data and has issues with performance due to large data. I will show you a couple of techniques you can apply to cope with large data and make your users not suffer too much due to delays and excessive resource use, like memory and CPU. I will show you an example application which is working with sound. And it has a long history, although the application is only maybe 2 months old. I've been thinking about it. I have built it for myself. I plan to have one session about writing software for startups in autumn this year. I'm not ready for that yet because I don't have statistical data for what I'm doing. This application will be an MVP at some point in time. Right now it is very rough, but it is doing what I intended it to do. It is helping me produce sound for my video courses. And since video courses are, as people say, the 21st century library, there are many thousands of people doing that out there, and I hope that at least some of those thousands of people, authors, will find software like this useful. So I will show to you how that progresses later in a couple of months. Right now I will show you a part of the application, and I will implement one feature in it which will actually not have to do directly with sound. You will see there is this audio processing library, there is this text library. I will actually not show you those libraries because dragons are living there. Those are secrets. But I will show you I will develop one feature regarding UI and business logic separation today. And before that, I will talk to you about large data. So, large data when it comes to sound is really large. I have prepared two audio files, which are raw recordings. I'll open the short one, which is only 1 minute of the recording, for you to see it, what it looks like in a typical sound processing editing application. Audacity, it is an open source application. If you're doing anything with sound, I will recommend this application to you. When someone records sound, for example, for the video course, it typically looks like this. There are streaks of talking. If I make a mistake speaking, I will repeat the same sentence again, maybe again and again. Here I'm repeating several times. Whenever I make a mistake, I snap my fingers like this so that I can see the mark in the recording. Listen to this.
Hello and welcome back.
Okay, and then I repeat
Hello and welcome back to the course on design patterns in C#.
This is actual recording from my latest course. And this is what the first minute of the recording looks like. And then comes the process where I have to fix all this sound, like removing those segments that I'm not satisfied with. Okay, this sentence is repeated. I will delete. You get the picture. This sentence has been, this part of the sentence.
And then to let up.
Has been repeated 4 times before I got it right. So I have to delete all these.
Straight code, which is lacking one special kind of flexibility. And then
I see that this pause here is too long. This is one sentence.
Flexibility. And then to let up.
This is better. You get a point. I have spent some 3 minutes without even completing the first minute here, without even hearing it, not a single time, And that costs me a lot. That costs me some 5 hours of working per 1 hour of sound. And that is very expensive. So I wanted to let software do that for me. This was about making a startup again, making an MVP again. But you see, these audio data are large data, and even opening the entire recording for just one clip, and I have some 50 to 70 clips in the course, just opening it up takes some 12 seconds only to open it. And it takes about maybe an hour or two to just remove these repetitions, to measure pauses between sentences, to remove background sounds, stuff like that. It takes a lot of time. And this is actual recording for only one clip. It is 14 minutes long, and clip after producing sound is only about 7 minutes long. If you have ever made any MVP for the market, you know there's some slang used there. One of the terms used in startups is pain point. You need to identify what is hurting the user. If you were watching episode 0, I have mentioned those problems that are hurting users. I'm hurt by spending long hours editing sound. So I want to fix that. How do I fix that? By making an application, a program which is replacing me. And this Audacity is not useful in that respect because it is general. It is too general. And so I got onto work. I first wanted to attack one smaller issue, because editing sound in an intelligent way is a very complicated problem. So I came up with a smaller problem first. And I always advise you, when doing something that is R&D, research and development, not just making a kiosk application, when you have to think, when you have to investigate, when you have to come up with algorithms, to first take a smaller, much smaller problem and to try that first. These secret projects here, audio processing and text, they have some 50 or 100 classes there. And many of those classes are very not complicated. They are all, each of them is doing one thing, all right. But those things are well beyond trivial. While I'm here, I will also show you one additional project I have here, the concept. Sometimes when doing R&D projects, I also add an assembly, which is a console application named concept. And there I play with things that I still don't understand. I am writing one specific feature, tiny feature, not thinking too much about how nice my code is, how well formatted it is, nothing. I just want to understand the problem. I just want to have a working solution for one tiny detail. Here you can see I was experimenting with something, I don't remember what. I was using one class which is mine, audiophile, and I was using my audio player class. They have interfaces which are quite different from system audio player, from other libraries, because they are doing things that I need when processing sound in this way that I need. And then I made something, some little feature. I think I remember I was about to add one API to this audio player. I needed something. So I was playing with it in a separate project, and I was changing the class. I added one function to it. Yes. And when I made it work just on one, let me show you the program. Here, I am hard coding the input data. These are some intervals of time in milliseconds. And I'm doing stuff. You see, everything is hard-coded here. I would invent one additional feature. I would have a modified class, and then I just move that modified code to the actual project, commit them, and make them public. Make them official, not public. That is the process which I'm applying to implement those not heavy but complicated features, those features that ask for a lot of learning and experimenting. Processing sound, as I said, is a complicated matter, so I took a bit easier problem, and that is generating subtitles. It also depends on understanding sound. This audio processing library I made is combining speech recognition with some complicated and advanced text matching and processing algorithms, so that I can cross text which is recognized from audio and text which comes from the script which I'm reading into the microphone. I'm using those two sources to cut segments of the audio file. German Keber has asked the question, why do you not use test project instead of concept project? Okay, because I don't know what to test. I don't know what API I expect, because I don't know what capabilities there are in libraries I'm using and in algorithms that I'm just about to develop. Therefore, I have no clue what to write. So I'm experimenting. I'm making steps in the dark. And when I do, then I will have some API which works and works the way I need it. I might write tests after that, but if you observe this entire solution has no tests at all. The reason is very simple. When you're working with sound, if you ever did anything with sound, when you make a bug, then it is very obvious when you play it on speakers. There's no way to make subtle bugs with sound. On the other hand, I was applying very complicated processes to compare the output of my methods with manual measurements in different applications, including Audacity. And when I figured that my algorithm is producing the same values as those reported by the low-level software, see, you can get to the level of microseconds here, and if I see that my program is producing the same thing as written, this is actually the WAV file, not MP3 file anymore, the same samples, the same results of calculations as when I apply them manually, then I know that my component is working right. Why don't I write the test to prove that then? Because I will never change that component again. I know that it is working now, and I know that I will not touch it again. It will only be composed into larger pipelines, processing pipelines later, but that component itself will work right. Therefore, I didn't need tests. On the other hand, if you saw repository on GitHub, where I have developed a parser and compiler, that thing is full of mathematical convolutions, stuff that is very mind-bending. And that project is covered with tests because I needed them. Decision to introduce automated tests is not automated in my case. Some projects I deliver don't have tests at all. The smaller problem I wanted to tackle before producing an automated sound editor was to generate captions, subtitles for the video. If you watched my latest course at Udemy, and if you switched subtitles on, then you will be happy to know that those subtitles were automatically generated using this software here. Okay, this very solution was applied to generate them. I am also preparing a market investigation whether some other authors also need the tool like that, and I will show you slides as far as I have got with them. I only need to complete the slides, and I will put them online in a few days, hopefully. I will show you how the application that processes sound and the transcript works to generate subtitles which you can upload to YouTube or to any video platform like Udemy or Pluralsight. You can upload subtitles and they will be synchronized. They should be generated in such a way that they are fully synchronized with the video. So this is the process of generating subtitles for a video. Okay, this is marketing stuff. Forget that. This is the point. You're generating captions or subtitles. I still don't know what is the right name for them. And this software is automating that. Okay. And here is the substance. It starts from the recording and the transcript. It is very important because without the transcript, speech recognition will be crap. And it is recognizing audio, indexing time, and then trying to match what it heard with what it was reading from the transcript file. And sometimes there will be discrepancies, and the tool will ask the author to step back and correct the transcript before it is aligned with the sound again. All these steps are done automatically. That is what the tool is doing. And when that is done, it will generate raw subtitles, which can be easily displayed and naturally displayed on screens of different sizes. And after that, you will be able to download actual subtitle files in different formats. And that is what this tool is doing. That is what some of the, you will see commands here. Some of these commands are actually creating those subtitles. So that tool was a success from my point of view because I could create subtitles for 5 hours of videos in no time. And that was wonderful. To show you how they do that, I will go to command line arguments and break them so that you can see the usage of this application. This is command line tool. Funny thing is that I have implemented a few commands that are generating those subtitle files. I would index the transcript first and then use the audio file MP3 and the transcript to construct either VTT or SRT subtitles. I have simply applied these two commands to all modules, all clips in the course, which is 5 hours long, and I generated subtitles for them. And that was a huge time saver for me because I think I have saved some 10 hours of work. I don't know. And this here is the long transcript. So now you see it all. This is the transcript which I was reading into the microphone, and this is the MP3 file produced in that session, recording session, and I used those two to generate subtitles. Now I want to use these two to produce an audio file which is completely edited audio file with the clip sound. And I want to do that for 1 hour of sound. I want to do that in 15 minutes. I don't want to do that in 3 or 4 hours. That is my pain point as a user. And so we have big data. Not big data, large data. We have large data that take 12 seconds only to load without any processing at all. And you will see that only recognizing speech takes more than a minute. Do you want to wait for a minute? No. And so we come to the essence of the first part of this presentation: how to process an MP3 file and produce the output MP3 file without spending too much time, without making the user wait for a couple of minutes for anything to happen on the screen. I have a couple of commands that are doing that. I am making a pipeline, a processing pipeline. These commands here are the new ones. If you look closer, you will see that they are written differently in the usage than these old ones. I have effectively improved the way I am thinking of that processing pipeline, and these two commands, which helped me so much, with which I was so happy, will in fact become obsolete in a month or two. If you disliked my decision to make a console application which is processing sound, then I'll tell you what. This application was always meant to be thrown away. And if I made a GUI application, I would spend days about the GUI interface itself, just to throw it away. Instead, I made commands, which are cheap, which only take 20 lines of code. And throwing away any one of them is spending 10 minutes of my life. Why I'm telling you this? Because when you are doing research and development, don't spend time on GUIs, on web, on things like that. You probably won't need that. You will write everything again when you figure out what you want. When you begin an R&D project or any part of it, you probably don't understand the problem well. And until you do understand it well, you will want to do everything from scratch way differently. So make that first attempt cheap. But as you progress through it, the parts that turn out good should be encapsulated in their own classes, in their own interfaces, abstractions, everything, and pushed to a separate project which is permanent. Okay, so the process of manipulating an MP3 file, which is considered a large data, goes like this. I will report a transcript so that the application can index in a specific way, read the plain text and index it the way it likes. It needs to read audio levels to discover intervals of silence. It needs to recognize speech through the entire file so that it knows what speech recognition engine thinks that I have said in specific intervals of time. It will then use the information gathered here and here in these two processing stages which go independently from one another, and it will outline talking streaks. Those are the intervals of uninterrupted speech. It will try to match what speech recognition engine said that it has recognized with the transcript. So this is the third stage which went in parallel. It will merge what speech recognition engine says and what the transcript says. And it will say transcript is right, speech recognition is wrong, typically, but there are great similarities. So it will apply text processing algorithms to try to match these with each other's, and then to say that some speaking streaks are actually incomplete. Those are errors. Those are the parts of the speech that were repeated later. And it will mark them as repeated. And then this purge command will actually remove them, plus cut the speaking streaks and paste them, move them closer so that pauses between them are natural for human speech. And it will eventually produce an output MP3 file. To show you how that works, I will fix this command line so it is going to purge. Observe what I am doing. I'm not activating any of those stages I said. No transcript, no indexing, no streaks, isolation, nothing. I just say I want this tool to purge my audio entirely. I'll run it. And you will see something that will probably stun you. But first, look what it is saying. It is processing the MP3 file. The short one, 1 minute long, because I don't want you to wait for 2 minutes before anything appears. And this is processing large data. Okay, it has recognized text, discovered the levels, intervals. Where are streaks? I don't remember what this is doing. It has cut the intervals of speech. Yes. Here are the text streaks, and I bet you didn't expect this. A plain text interface. But it has a lot of commands here. These are not actual buttons, but reminders for me what commands this application is supporting. This was the test bed for me, the live test bed for me. I could make transforms to the audio, any transforms I liked, and I could play with text, I could play with audio, I could do different things and develop commands, and whatever I created that works on sound or on text, I pushed that into specialized classes and pushed that into permanent projects for audio processing and text processing. So I was effectively performing R&D, research and development on this problem domain. But what is more important, and that is what the first half of this presentation is about. You remember how much time it took to open the window, to just open and show you the content. Let me run it again. It's reading MP3 file, and it says, this file already exists. Poof, open, done. It didn't do any processing at all on MP3. It just had to decode it, and then it used the results of previous processing stages, and it was operating on plain text files that are indexing, explaining what is where in the audio file, what was the result of speech recognition, what was the result of matching speech recognition with transcript, what were the time intervals for every sentence, every part of the sentence. All those data were stored in files, in text files that take milliseconds to process, to read again. And now listen to this.
Hello and welcome back to My name is Zoran Horvat. In this module we will...
Okay, I'm using keyboard to walk through the audio. You can see that this was recognized poorly. This was good, but what is this? I don't know. And then look at this. This sentence, these colors indicate different confidence levels that my algorithms have produced. They say that this is probably a repetition of this, but there are huge differences between these two, and the application could not make an automated answer. So what I'm doing to produce sound, I would exclude with a delete key and exclude this one,
and then to let a parent come to the rest.
Stop. And this would be the final text as I want, the final speech as I want it. When I press enter, it will produce, you see, in 1 second it has produced the output MP3. If I go to that directory, where are you? Okay, output MP3, this.
Hello and welcome back to the course on design patterns in C#. My name is Zoran Horvat. In this module we will cover one simple...
If you observe, the speech is natural. Everything was cut and put into place, into final place where it should be. Everything. This is what I want to have. But I want it to work even better. I will show you internals, how this application did all this. How did it process this large data? Here is the answer. This sound directory is the cache for everything my application has produced. Why I'm caching it? Or, even better question is, how do I know that these cached things are safe to read later and to use in subsequent processing? The answer is very simple. They are attached, they are associated with this MP3 file, which is immutable. And therefore, whatever processing I apply to the file, I can save the result of that processing into a document, and that document will remain valid so long as the MP3 file is not overwritten by a different MP3 with the same name, but I'm not going to do that. Now you may complain that this is the file system which generally allows me to do that. Okay, if that is the case, you don't expose raw storage to your users, but you expose a service to upload an MP3 file. And there is no API to upload new MP3 file and overwrite the existing one. You can only add it side by side. And if you do that, then all these processing stages would be triggered again at full price, and the user will have to wait for the first pass through the data to happen, to complete, before continuing with editing. All right. So if I went back to the application and said, don't use the short one, but those 14 minutes long audio, that will take 2 minutes to complete. So while it works, I will have some 2 minutes of spare time to tell you another interesting thing about processing large data. You can cache intermediate results. You can cache intermediate results of intermediate processing stages. When processing large data, you will invariantly want to build a processing pipeline. You don't want the entire process to be just one monolithic block, simply because you will not have intermediate data in that case. And if you separate all processing stages, you will have intermediate data. And if you succeed to make the input file immutable, the input data, whatever it is, then you will be able to store those intermediate results. And then your pipeline will consist of smaller blocks which are smarter. They receive the request, and then they first see if they have the cached answer for that request. If yes, they produce it right away, and that takes milliseconds. If no, they perform processing, which typically means to ask 1 or 2 other blocks for their own output, combine them, apply some transforms and things like that. So that will cost you. Okay, this is when the speech recognition has completed for 14 minutes of MP3, which is not MP3 in memory, it is a WAV file in memory. So it took 12 seconds of CPU time to first decode MP3 file, then another probably a minute or 50 seconds to recognize it, and then I have applied another algorithm, which also took some 10 seconds to establish silence level at minus 34 decibels. Then the next stage requests that again, but this time this file exists. I will not analyze sound levels again. I will not, because that is cached already. And now I'm using that silence level to identify intervals of speech. And then I'm applying speech recognition to each interval in isolation, because in that case, speech recognition engine actually produces different text. That is the funny fact. So, I explained you about intermediate results. There is one more thing. What if you got a better idea? What does it mean to have a better idea when you have a complicated pipeline of processing blocks? It means that you will create more blocks, new blocks, and add them into the pipeline. That will produce some disturbance. Okay, here it is. It has recognized again. And then comes my code, which is analyzing streaks, matching them, detecting repeats. And right now I think that it is decoding MP3 again to load it into memory. Here it is. You have 14 minutes of speech displayed here after 2 minutes of work. 2 minutes of work. Let's start it again, and you will see it open in, you see, it already exists. It will be open in 12 seconds. That is how much of CPU is required to open the MP3 file, only to open it. Everything else is in text. And now I can...
Hello and welcome. My name is Zoran. In this mod,
this is the long, the long version, and you can see that the tool was not certain about things that are obvious to me as a human. And this is what I told you. What if you got better idea? Now I have a better idea, not just to use the speech recognition output. These are obvious repetitions, and I will have to manually remove them. I want my tool to perform better. So I will match it with a transcript. So those are the new blocks I'm adding to processing. How does that interfere with this process? Let's see the cache. It has grown significantly because now I am producing, whereas reduced, these are the cached outputs for that large file. You see, these levels has 1.5 megabytes, but all others are only 10 or 2 kilobytes in size, 40 kilobytes. Those are the cached products of intermediate processing stages on large data. They take 1 millisecond to read and deserialize. So I don't have to repeat processing again. But still, after having all this done in my project, I have added the transcript. And I have one stage to process the transcript file, which is textual file. It doesn't incorporate working with sound, so it is very simple, very cheap. I have another stage to match that with speech. And I will show you what happens with this cache when I introduce transcript. So I'll get back to the transcript, and I called it mo2co1txt. Okay, this should work. I will run that, and now you will see what will happen. Let's see what it will say this time. It has generated in 0.66 seconds. It has generated the transcript. Who's new here? This one is new. You can see the transcript file, which is the same text as that input, only broken into sentences. I am expecting one sentence to be one speaking streak. So I have enlarged this cache. And now I will purge it again, and you will see what will happen this time. Out MP3. Okay. Watch this. so it needs 12 seconds to read MP3. Okay, intervals have not changed because I added transcript. So this stage did not notice anything new, and it has just produced the output from cache. What is happening under the hood is that one of the stages has noticed the transcript, and transcript is optional in that. I made it optional in that processing stage. This stage, which is executing now, has just figured that it has that transcript available, and it will apply a more complex algorithm to match that with the output of speech recognition. It will apply a few heavyweight algorithms to match characters, words, sounds in speech. Very complicated stuff, very costly. Why doesn't it end? Okay, here it is. Look at the name of the file. It has added .transcript. So now I have a different cache, more specific cache, and all subsequent stages will also look for optional transcript to improve their output. And now we are close to the end, I think. Yes, now you see it. These sentences with capital letters and punctuation are from the transcript. These with no capital letters and no punctuations are from speech recognition, because speech recognizer has no clue where to put punctuation and where to start the new sentence. And so you will see here that these sentences have all been matched with the transcript, and now the confidence level produced by my algorithms, confidence levels that part of the speech is repeated later, has grown beyond the threshold, and the application was able to remove those sentences automatically. Again, if I close it and run it again, it will use all those cached files with transcript in it, in their name, to load the pre-processed data that include transcript, and you will see that capital letters and punctuation are also, again,
Hello,
here.
My name in this
and this
module
makes time I spend as a user in this application, it will cut it to half. So I have a clear benefit as a user from this new development. And now we get back to the question. What advantage as a user do I have if I already had to wait for 2 or 3 minutes for this interface to open? Look at this cache. What do you see? These are all outputs of intermediate processing stages. They took 2 minutes to produce. You can even see that. You can even see the process, how the process went. At 1:43 it started, at 1:45 it ended. It's 2 minutes of your time waiting the circle going around on your screen. The answer is that you don't have to wait for that to complete. Because since I do have caching implemented, I can do one not so obvious thing, and that is, remember that service which is allowing you don't need to wait every time? Abhilash, yes, you don't have to wait every time, but how often will you actually open the same MP3 file twice? Not so often. You will actually open it once, process it, produce the output, and be done with it. So you will have to wait for 2 minutes. Since I do have caching in my entire processing pipeline, I can do one special thing, and plus I do have a service for you to upload MP3 and transcript. as you upload MP3, as that commits somewhere in my system, which you don't see, and you still haven't switched to the page where you would process MP3. I will do one thing for you. I will touch it for you. Asynchronously, as I refer back to you saying your file has been uploaded correctly, asynchronously at the back of my system, which you don't see, I will touch it. And the entire pipeline will execute, producing cache, populating cache. That concept is called warming up the cache. If you have caching of intermediate results, then you can produce them before the user comes. And now imagine yourself as the user. You are recording sound. As you finish, you will probably take some water or take some coffee or go to the toilet. And when you get back, the cache will be full. And that's the point. You will never see those 2 minutes of delay. And you only have that option available if your large data are immutable and you have well-separated processing stages, which construct the pipeline. And that is all. There's one thing I didn't mention. Why I didn't put this to database. It's not really that would cost me too much. If you observe code, I will show you how I created these files. I have models here, and I have serialization to string and from string, two well-defined strings and from those strings. So I could simply save a sequence of objects into a file as a sequence of lines and then just read them. That was cheap. Putting that into the database would not be that much more expensive. Plus, I might benefit from that. Yes, Zoko, that is basically right. I can experiment with text. And I can read it easily. I just open the file. I'll show you the files. Streaks, repeats. Let's open this one. Do you know what this means? From this millisecond to this millisecond, I think that it is 40% chance that this text was repeated any time after. And from this millisecond to this one, I know for sure with 100% certainty that this was spoken again. And that is how that subsequent stage operates. It reads these probabilities and puts thresholds. And it says, if, I don't know, more than 90%, mark this as deleted. If more than, I don't know, 70%, mark this as probably so the human can change the color of it so that the human can see that there is something happening there and think about that. If it's more than, I don't know, 80, put it in red. It must be screaming. This is almost certainly repeated, but I'm not sure. You know, that is how the tool is working and helping you. And this is the representation. Ashad, thanks. Any particular reason .NET Framework and not Core? Yes, there is a particular reason. The speech recognition library is not ported to .NET Core. Yes, I would get additional performance out of Core. And when speaking of that, I plan to keep speech recognition part of the project in .NET Framework, expose it as a service, and then consuming from a .NET Core service which would benefit from performance, so that I can that is basically a non-functional requirement. I cannot use .NET Core for the entire solution, so I will split it into two, those that are bound to legacy libraries until they become available in Core, and those that would really benefit from improved performance into .NET Core. Thank you, that is a good question. Okay, where was I? Let's pop to the question of why not database. Why not database? Because I didn't know the schema. That is the point. I was experimenting. What would I store in the database? And which kind of database? These are the documents. I would prefer saving these as XML documents in the database, because I could read them very efficiently. And then, what documents? I was still experimenting with that question. I sensed that there is the way to cache. There is the way to cache data and reuse them, but how exactly so that it works right? Caching is a slippery slope, always. Always. You have to think carefully about caching, because if it turns that your cache is stale, your downstream pipes will simply produce incorrect result, and that is a catastrophe. There would be required a lot of thinking about schema and spending precious time designing DB and later certainly changing it. Yes. Especially the changing the database is a problem. It is an expensive exercise, because when you change schema, you will have to transform historical data. All the data that are already there, you would have to transform them and save them again. Here I just delete them. I'm not, there is one, I don't remember exactly which was that. There was a Unix command which is awkward, very awkward. I really don't remember which one it was. And the authors of Unix have a legend about it. People are now asking them, why? Why that way? This is awkward. Why didn't you do that more elegantly? And they say because of the backward compatibility, which is true. Backward compatibility is a virtue, and Unix was exercising backward compatibility meticulously in many ways. And that was one of the examples. But then one of the authors, original authors of Unix, explained why that was a mistake to retain that command, because back at that time, when they noticed that it's not the best idea, they had 100 users of Unix who they didn't want to disturb. So they retained it. And now, decades later, they have hundreds of millions of users who are suffering. So you can experiment cheaply while your data are small. Just delete them. And say, you guys, you early adopters, you knew that this will happen. Sorry, I deleted all your files. Upload them again. You can do that early on in the project. But once you go to production, you don't have that benefit. You cannot just delete caches, because people will start calling your office and saying, oh, the application is very slow, it was fast. And you say, no, it will be fast the second time. What second time? I'm editing file only once. So everybody will wait worldwide. You don't want that to happen. Okay, Ershad, all the options are open. Thank you for noting. That is true. Basically, that is true. You leave the options: distributed, cache, cloud computing, everything. Yes, all the options are open. that is one of the principal reasons why I didn't fix storage, but I left it the cheapest possible, plain text file. Not safe. Do you know what my application is doing? If I delete one character here and at the sensitive position, it just reports that it cannot continue. It is very simple. That shouldn't happen with proper storage, and proper schema, whatever it is. The point is, the principal reason why I didn't use any real storage, whatever it is that I didn't know what I want to store. I wanted to learn more. And now, 2 months later, I know exactly what I want to store. I want to cache documents. I don't want to look for 100,000 rows in a database which can be zipped to 50 kilobytes of XML. And I want documents to be precisely signed. So I need a signature of every document, because every processing stage must say, when I receive a request, if I have the answer to this request, I will produce it from cache. If I don't, I will reproduce it again and store it for future use. So what does it mean? The answer to this request. It means that I must sign the request, all parameters of the request. I must sign the algorithm implemented by this stage. What is its name? How do I call it? And the version of that algorithm. And the sources. But those are also parameters. So these three things, parameters of the call, the algorithm, and the algorithm version. All these things must come into the signature, plus any optional components, any intelligence built into the stage would also get into the signature of this of the output to this request. So you see that there is a transcript version and non-transcript version. Whereas these two files are the same thing, but produced from two distinct requests. And those two requests had the same parameters. The caller didn't know whether there is a transcript or no. That is the knowledge possessed by this component that produces this document. So it effectively produced two documents. And that is the actual reason. Can we have some code walkthrough for this application? The answer is no, because this code is secret. This is the novel application. I'm not aware that there is any similar application out there, so I'm not going to show it in the next couple of years, probably at least. So sorry, that's why I'm holding those assemblies closed. I will keep them closed. These are the important parts. These are the algorithms I have developed during the last few months. We have a question from Edward. At this stage, would you say this application is a very fast pencil? In previous episode, I was talking very hard about very fast pencils. So, why I don't think that this is a very fast pencil? This is not really... No, I don't think that I'm trying to run away from the question. This example, editing speech sound, is not really applicable to that theory, because when you're editing speech sound, you simply have to cut out the damaged parts. You have to glue them together. In a way, it will always be like that. So I don't know how to answer this, because there is no other business logic in this business than cutting and pasting sound. But on the other hand, I am moving focus from editing operations to declarative commands issued by the user. That declarative programming model, the declarative UI model, is something different which I didn't speak of in the previous session. It is equally important as that fast pencil fallacy. When you are developing a UI, you want your user to indicate intentions, not to work on them. Maybe that could be said that this is not a very fast pencil. I am not selecting audio in my interface. I could even implement it in plain text command prompt, because there's no audio wave anywhere. So I am, in a way, moving the focus away from editing sound to simply telling what editing should be done in terms of which speaking streaks to include and exclude. And that is also, maybe this could also be viewed as not a fast pencil, but something completely different. In the end, I just press enter in this interface and I get my MP3 out. That's it.